hearing this?
Anybody hear that?
How can we possibly have the slightest idea what to expect?
Well, we're back.
Hold on to your butts.
Welcome to the Jurassic Park podcast. I'm your host, Brad Jost, and we're here to discuss all things Jurassic, including the movies, TV shows, music, toys, and more. In episode 404, Conor O'Keefe is back with another excellent Dino DNA. This time he chats with paleontologist Caroline Abbott about a couple of lovely little creatures that you may have seen in the last Jurassic film, Jurassic World Dominion, the Lysosaurus and Dimetrodon. And me listening to this episode proves that I may have been saying their names wrong this entire time. So, apologies. But that's why we bring awesome people onto the show, like Conor and Caroline, to discuss such things, just to set the record straight. It's a wonderfully in-depth conversation, so please don't miss it. But of course, while you're listening to this episode, hit us up on Blue Sky to continue the conversation. And as always, please check out our live streams on YouTube discussing all of the latest Jurassic news from around the world, Wednesday nights, 9 p.m. EST. Also, be sure to subscribe to my newsletter for all things Jurassic, movies, TV, my podcast, and other thoughts and appearances. Find the link to the newsletter on JurassicParkPodcast.com/newsletter. And just to continue the preamble a little bit here, I feel like the excitement is growing for Jurassic right now. We are potentially, maybe, in our final week here before we get the trailer. We have to wait and see. There could be a trailer this Super Bowl. That's what the word has been hinting towards. So keep your eyes peeled towards a Super Bowl. Hopefully we can have a lot of coverage out next week if that is the case. But it just feels like the excitement's growing because of that potential trailer, because of, synopsis and things for Jurassic World Chaos Theory for Season 3. We've seen a little bit of a tease for an upcoming animated show, Jurassic World Explorers. New toys, new games, so much stuff to discuss. So I feel like this is the calm right now, and we are just kind of sitting in it. This is the before. I know when we used to do the mailbag all the time, Jennifer Evans, we would always coin this, the before and then the after. And we are in the before. We know a little bit, of course, but man, the after is coming up really quick. So just savor this moment before we get everything that we've wanted from this franchise. So let's stay tuned. But hopefully we get a lot of big stuff coming up this weekend. I'm keeping my fingers crossed. But that about does it for the intro. So why don't we go ahead and dive into the conversation with Caroline Abbott and Conor O'Keefe about the Lysosaurus and the Dimetrodon.
Well, maybe dinosaurs have more in common with present-day birds than they do with reptiles.
You do understand these are actual animals, right?
You read about them in books, you see the bones in museums, but you don't really believe it.
You should hear a 4-year-old try to say Archaeornithomimus.
I read both of your books. You liked dinosaurs back then.
All vertebrate embryos are inherently female anyway. They just require an extra hormone given at the right developmental stage to make them male.
You know that I'm not at liberty to reveal the asset's genetic makeup.
Nothing in Jurassic World is natural.
You will see a herd of the first dinosaurs on our tour, called Dilophosaurus.
How would you classify it, Billy?
Suchomimus, snout.
No, think bigger.
Baryonyx.
Spinosaurus aegypti. Actually, Charlie, those are herbivores. They really wouldn't be interested in fighting with each other. But these ones here are carnivores, and they really like fighting with each other. They use their teeth and their claws to rip each other's throats out.
He's 3. Let's wait till he's 5.
Hello everybody and welcome to Dino DNA on the Jurassic Park podcast. I'm your host Conor O'Keefe, and this is the show in which we look at the real world animals that inspired the dinosaur and other animal creatures that we see in the Jurassic Park films and TV shows. So today we're going to be looking at a group of animals that were recently introduced to the franchise but aren't exactly dinosaurs. And to help me with that, I'm joined by paleontologist Caroline Abbott. Thank you so much for joining us, Caroline.
Thanks so much for having me. I'm really excited to be here.
Awesome. So yeah, we'll be talking about Dimetrodon and Lysosaurus. In terms of pronunciation, we'll be talking about those a bit later. But Caroline, can you tell us a little bit more about your work and what your day-to-day looks like as a paleontologist and where you're based as well?
Cool. Yeah. So I broadly work on this really cool group of animals we're going to be talking about today, the synapsids. We'll talk in a little bit about what exactly that means, especially with respect to the dinosaurs that we're used to seeing in the Jurassic Park franchise. And I was really excited to talk about these two animals today because these animals are actually the ones that I have worked the most on for my research. So for my undergraduate work at the College of William and Mary, I worked on Dimetrodon for an undergrad project. And then now in my PhD work, I'm focusing on Lystrosaurus for my research. So it's pretty cool to talk about those. And I'm currently in my PhD at the University of Chicago in Chicago, Illinois, and the Field Museum in Chicago, Illinois.
Fantastic. Well, yeah, I mean, I've got so many questions about these animals. Like, they're kind of a blind spot on my knowledge to a certain degree, and I'm sure they are for lots of people. Do you get, I imagine at the not necessarily the university, but the museum, you probably get quite a lot of questions about why is this not a dinosaur and such. So actually, that's going to be my first question. Why are these animals not dinosaurs?
That's a great question. You're exactly right. That's like one of my favorite questions and like one of the most common questions I get when I'm working with folks at the museum and the university. So both Dimetrodon and Lystrosaurus are examples of synapsids, as I mentioned before. And synapsids are a group of animals that includes modern day mammals, as well as their ancestors and relatives. So you might hear the word mammal like reptile thrown around a lot or proto-mammal. That honestly kind of does these guys a disservice because they've never been reptiles for one.
Oh,
Their
wow.
reptiles are completely different side of the tree. So you can kind of think about like 310, 315 million years ago, you have, say, this little amniote, so an early egg-laying animal that's living on land. It's not an amphibian. And from that early amniote, you have two splits. You have the reptile split, and then we have the synapsid split. And part of the reason I don't like the word proto-mammal as well is because, again, we have modern day mammals as one group of synapsids, but it'd almost be like if you called all of dinosaurs proto-birds. It just does
Right.
this group
Yeah.
that has so much diversity a disservice because you don't want to call Triceratops a proto-bird or
Yeah.
Stegosaurus.
And it makes
Yeah.
it feel like they're only like a transitional stage, right? It makes them like a prototype, like the first version of something. It doesn't do justice to the fact that they're their own complete group of animals.
Yeah. Yeah, exactly. Yeah, they're a really incredible group and they helped form the first terrestrial ecosystem. So from that time where you have that split around 315 million years ago, up through about 252 million years ago when we had the end Permian mass extinction, the non-mammal synapsids just dominated the world. Reptiles were very much, there were some reptiles that were in the foreground, but it was really synapsids that were running the show. And even going into the earliest Triassic, we still had some of these like really cool large synapsids and like smaller ones too, but the non-mammal synapsids, even around the time of the earliest dinosaurs, were really still on the scene. And it wasn't until the Jurassic that we kind of lose the rest of that diversity. And it's just, the typical little tiny mammals scurrying
Yeah.
underneath the feet of dinosaurs situation. So,
Yeah.
yeah.
Wow. So like there was such a huge and successful group of animals. We'll be narrowing down onto the two that have appeared in the Jurassic series so far. So both Dimetrodon and Lysosaurus, they first appeared in 2022's Jurassic World Dominion, which was really, really cool. It was the first time in any of these films in which we saw extinct animals that weren't from the Mesozoic, which was like a first. And then also it feels like this is probably done to show that different genetics companies had different kind of ways of collecting DNA and resurrecting creatures. So what we'll do is we'll go through Dimetrodon first and Lysosaurus and see how the film's character design stacks up against what we know of the real world animal. And just a kind of disclaimer for everyone listening, like we're both quite big fans of the Jurassic series, and we really like these movies and how fun they are, and the creature designs are definitely something that I know I obsess a lot about. And just before we started recording, actually, Caroline, you had a really nice way of like describing how you see these creatures. Do you want to let the listeners know as well?
Yeah, of course. Yeah, so I'm a huge fan of the Jurassic Park franchise, and I think like for both of us and like many of us listening, it's one of our first ins to the world of paleontology.
Absolutely, yeah.
Yeah, and for me, as I've sort of learned more about the accuracies of paleontology and dinosaurs and synapsids, I kind of look at Jurassic Park creatures almost as like kaiju, so like movie monsters that are influenced by our human perception of how these creatures would be. So, yes, they are reflective of the actual biology of these animals, but they're also they have our conceptions of them placed over them as well, which is like a nice way to, at least for me, to think about them.
Yeah, I think that's a lovely way of thinking about them. Yeah, I always like thinking of them as also like film characters, because they're designed in a certain way to evoke emotion. And these next two ones definitely were really charismatic in the films that they were in due to some choices made. So yeah, let's talk about them. So Dimetrodon, so it was originally discovered in the USA, in the Southwest, but has also since been discovered in Germany. And this was in the 1800s, mid 1800s, and was actually first incorrectly described as a dinosaur, which is quite funny that you still get Dimetrodon toys in dinosaur toy boxes and stuff. And yeah, the first fossil ever discovered, it was mistaken as well. That's quite funny to me.
Yes. Yeah, I actually collect it. It's a shame that I'm not in my office at the Field Museum right now, because I collect like terrible reconstructions of Dimetrodon.
That's great.
And yeah, most of them are coming from like toy bins that are like dinosaurs. So I'll like, pay for this huge tube of plastic dinosaurs that has like the one Dimetrodon I haven't seen yet in it.
Yeah, there was actually one that I've got on one of my desks, which is it's just Godzilla from a toy tube of dinosaur toys, and I just could not. It's just Godzilla. Like there's nothing about it. I was obsessed.
That's awesome.
So Edward Drinker Cope, who's someone that we've spoken actually quite a lot about on this show, who played a big part in paleontology in the USA. He found a fair bit of material in the 1870s of Dimetrodon. And something that probably a lot of people don't know is that he found material from different species, that there's actually more than one species of Dimetrodon, isn't there?
Mm-hmm. Yeah, this is actually a point of contention, because a lot of this is, I mean, it's true for dinosaurs, of course, but just because synapsids aren't worked on as much, there's definitely multiple species, but I work a lot on growth, and I have a strong suspicion some of these species are just like different parts of the growth series. Yeah.
Yeah, that's something that we spoke about with Ethan Harvey a couple episodes ago about Tyrannosaurus Rex as well.
Cool.
Yeah. So you spoke that earlier about these non-mammalian synapsids, as we're correctly identifying them rather than mammal-like reptiles as it was for like my entire childhood. We've got they kind of started their existence. They evolved in the Permian periods. That was before the Mesozoic. It was with Dimetrodon as well. It was around 40 million years before the first dinosaur even evolved, which is super cool. What do we kind of know about the Permian landscape ecosystems in which Dimetrodon lived in? Is there much information on that?
Yeah, so we actually have a decent amount of information, and a lot of that comes from both looking at the other animals in Dimetrodon's environment, but then also looking at the rocks. So you've probably talked about this on the show before, but paleontologists really rely on the geology of the fossils along with their biology to get a sense of what's going on. And so Dimetrodon's usually found in a type of rock that we call red beds. So these are typically sandstones and siltstones that are tinted red with iron oxide and other chemical compounds. And typically we interpret those kinds of rocks to indicate a wet environment. Now, part of the issue is that, we only get fossils in places where fossils are going to be preserved. So we don't know, were there Dimetrodon species also living in the desert? We don't really know because we haven't found fossils from like those environments yet. But the environments where we find Dimetrodon fossils are interpreted as being like floodplains or deltas. So think like lush, kind of like Everglades, tropical, but replace like your palms for like ferns and horsetails and things like that.
That's awesome. And actually, that's something that we kind of see a bit of in the movie. There's one shot of like a Dimetrodon. Actually, just before I get onto that question, I've been using the word Dimetrodon, and you've been saying Dimetrodon. Let's get this out there. What's the deal with the pronunciation here?
Yeah, so both are correct. So I even will switch between Dimetrodon and Dimetrodon. And it's really funny. I like have had instances where I love bringing Dimetrodon material out to the public floor at the Field Museum, and I've had children like correct me on my pronunciation before, and it's actually a great opportunity to talk about how like different pronunciations of scientific names can actually be correct. And it also varies by region too. So like for instance, like a lot of my coworkers are in South Africa, and like we have completely different, or not completely different, but just like slightly different pronunciations for scientific names sometimes. So yeah.
Great.
Do your best is usually what I tell people, but yeah, both are correct.
Fantastic. Yeah. I just wanted to get that out there in case anyone was confused.
Yeah.
So yeah, I was saying that in Dominion we see a Dimetrodon actually, it's maybe not swimming, but it's submerged in water. They're living in water.
Yeah.
So if they lived in floodplains, that's something they would have been around in real life as well, right?
Mm-hmm. Yeah. So the whole idea of if they were swimming or not is like a really interesting question. If you look at their body plan, they're not exactly adapted for swimming, or at least just like looking at the general structure of their bones. But as we know in paleontology, like the ecomorphology, if you see like a really strong signal, sorry, I'm throwing out ecomorphology, like we look at clues on bones to show us how animals behaved, right? And so if you see big teeth, you're probably going to assume that animal's eating meat. But also that doesn't mean that that animal maybe wasn't like snacking on a fruit every now and then. And so how I kind of think about that with Dimetrodon's behavior, like there's tons of animals that quote unquote shouldn't be swimming that we find swimming. Like I just found out recently that bats are actually pretty good swimmers.
I had no idea. That's crazy.
I know. So who's to say that there wasn't like a really delicious looking, like a Dilophosaurus baby or something on the side of the riverbank, and yeah, Dimetrodon just going like full send. Let's do it. Get across the river. But yeah, in its day to day, it probably wasn't the sewer gator style that we see in Dominion. Yeah.
I mean, like, I've got so many questions off the back of that. One of them would be actually around maybe, because I know that Cope also, he speculated that it could have been a swimmer, way back, back in the 1880s. That could have been perhaps because it has that sail on its back. And that was my next question was going to be around, it's got that huge sail, and it was also around the fact we see it living in a cave. I feel like living in a cave with a massive sail like that doesn't seem to work. So I was going to ask what that sail is for, and would it live in a cave? I can't imagine it would, but yeah.
Yeah, I want to hit the second part of the question because that scene was so iconic. I was so excited when I saw that. Because again, they really were like, they looked at Dimetrodon and they were like, sewer gator. Yeah. Because again, like you're saying, with its tall sail, it probably wasn't living in caves, and it probably wasn't like lurking in the water. The thing I did like about that scene, and we can talk about this in a bit,
Yeah.
was how slow they were. But to go back to your question about the purpose of the sail, so there's been like a lot of back and forth over, you know, with a lot of structures on fossil animals, we can't test true function unless we have like a really strong like analog, like a really strong modern example of seeing that structure in action. But with the sail, the two things that are thrown out the most are display. So something like Stegosaurus plates, where you've got blood running through the structure, or it's just super elaborate. So if you're a Dimetrodon with like the coolest sail, you like, you know, are the most dominant in your community, or like, you know, you're the best choice of a mate or something. And then the other one, which is especially interesting given that they're, you know, not closely related to mammals, but one of our distant ancestors, is that they were using this for thermoregulation or generating heat, like a giant solar panel. There's been some interesting research sort of looking at both theories. And neither is like fully definitive. Like we have some work showing like, yes, it could potentially be like a giant solar panel type structure, and others that are, it was probably display. So if you're going to ask me sort of just what I think it was probably a mixture of both.
Yeah.
But yeah, so we don't entirely know, but those are the two main ideas.
Great. Yeah. I mean, yeah, it would be really impractical to have that in a cave. It would get caught on rocks. Like, it's quite thin in terms of like, even in the film, we can see light passing through the sail.
Yes.
So yeah, that could get hit. And also if it's hiding in the water, that's a big thing saying, hey, there's a predator in here, big red fin sticking out.
Yes. Like a shark fin. Yeah.
Yeah. But I agree,
Yeah.
it was a really fun scene. There was a I don't know if you know this, but there was a Lost World game on the PlayStation 1 that came out in the 90s, and there was a level set in caves, and it was originally meant to be Dimetrodon in that level, and they cut them because they were too hard to animate compared to the dinosaurs that are in the rest of the game. So that's cool that Jurassic has a habit of doing that surrogated Dimetrodon kind of thing. Yeah.
That's so cool. I didn't know that.
Yeah. There's some concept art out there. Yeah, it's really cool. Actually, on that note about it being hard to animate, that's because it has a completely different posture from all the dinosaurs that we see in the Jurassic films and stuff. In the film, the Dimetrodon has its legs really out to the side, kind of like how you'd see like a crocodile rather than tucked underneath their body. So yeah, what do we know about their posture? And you mentioned also one circling back to, you know, their speed, and they made the Dimetrodon in the films really kind of like slow, and that was great, and it would like build up the tension. So is that linked in with its kind of posture, like its speed as well?
Yeah. So with regards to the posture, that was actually one of the things that I worked on for my undergraduate work, which unfortunately was pretty inconclusive. It was very much sort of like a starter project.
Right.
But if you look at the like architecture of the limbs of these animals and their limb girdles, that's things like their shoulder blades and their pelvis, they're really both robust, so like really blocky, and then also way more restricted than you would see. The movement is way more restricted than you'd see on like a dinosaur or a mammal. So I think that's part of why they're so hard to animate. And additionally, their backbones were much stiffer than both dinosaurs and modern mammals. So you have like essentially, I mean, think about it, like these things were living, the first amniotes period were around 315 million years ago. And then these synapsids are, you know, geologically not that long after. And so, yeah, they're still figuring out how to move on land. But the sort of like accepted posture, if you just sort of look at both like how they kind of move through the limb girdles themselves, and then also just watching animals move today. So that sort of like crocodile or even like a monitor lizard type movement, I think makes the most sense without like as much sort of lateral bending of the torso. So like you don't have that sort of like side to side motion as they walk, that swagger that you see crocodiles like on golf courses having
Yeah,
while their
yeah.
legs moving. Yeah. And yeah, sort of with that going back to the moving slow, that side to side movement that you see both gators and monitor lizards using is actually like a really efficient derived, so like evolutionary, like I don't want to say advanced, but like um it's something that's unique to these animals and isn't like a primitive form of moving. And so there's this great quote from Gillian King, who's this amazing South African and British paleontologist.
Yeah.
And she jokes about the Permian being a very slow world because you have these like clunky limbs and this like really stiff backbone. So you wouldn't have this sort of like, a gator can sprint at you at like 30 miles per hour or whatever it is. It would be like, oh no, the Dimetrodon's coming towards me and I can definitely outrun it. So, or I don't know if you like a huge one, if you'd be able to outrun it, but it wouldn't be as like terrifying as an alligator sprinting after you.
That's
Yeah.
I love that quote. That's really funny. And also like
Yeah.
I guess they stayed true to that in the film because the problem is that there's a door that's locked that stops them from getting away.
Yes.
Rather than being chased down, they are stuck in there with them. So they played up that aspect quite nicely.
Yeah, which I feel like that was probably for the movie drama, but I was pretty obsessed with that when I watched that. I was like, oh wow, they really got the like like slowly threatening aspect of it down.
That's
Yeah.
great. You mentioned there about you said like if there was like a really big one coming after you, and we mentioned before that there could be, but it's controversial, but there might be different species and stuff. The one in the film is around 4.5 meters long and about 1.8 meters high at the tallest point of sail. Is that kind of around the size of what we'd expect from a real Dimetrodon, or is that because they quite often like make things bigger in the Jurassic films for dramatic effect?
Yeah. So that's actually pretty accurate for the largest.
Cool.
Sorry, I don't know if you can hear the dog squeaking next to me, but
yeah, there's a dog. There's a mammalian synapsid. Yeah.
yes. Yeah. So that's actually pretty accurate for the largest specimens that we know of. So I think the largest Dimetrodon grandis that we know of is about the same size. So they did go for top limit, but they didn't go over the top with the sizing.
That's really cool.
Yeah. No, it's very cool.
That's awesome. That's good to know. So they are that big and scary in real life.
Yes. There would be all different kinds of sizes. So like, for instance, the one you were talking about in Germany, that one was only about 3 feet long, or like a meter and change. Yeah. So, so there's a really wide size range, but they really went for, and you can't beat Dimetrodon grandis. It's like huge and it has these awesome serrated teeth. So yeah,
Ooh,
good choice.
That's cool. Talking about the teeth, let's talk about the teeth.
Sure.
The ones in the films, they have like quite irregular teeth. They're kind of like pointing out at weird kind of angles and stuff compared to like the quite neat ones that you've seen in dinosaurs. But Dimetrodon, like the name, like literally means 2 measures of tooth. So like 2 types of teeth. I don't know if we really see that in the film design. Can you tell us more about like the real animals' teeth and how they kind of compare to the ones in the film?
Yeah, so the ones in the film are much more like pure conical instead of like the almost like teardrop conical shape that we see on the real animal. And also the organization of the teeth, like you're saying, was very different from like a real Dimetrodon. So if you look at Dimetrodon's jaws, if you look at its upper jaw, it has kind of like these teeth that are increasingly getting larger until you hit this big canine. And then there's a drop off, and then there's this structure that we call a diastema. And this is something that you see in modern teeth as well. And that's just basically a gap in your tooth. So like next time, you're like, oh, I see a gap in my teeth or in your dog's teeth or whatever. If you're like, that's a diastema. So yeah, so we have this gap called a diastema. And then we have another set of teeth, with like big canines and some smaller conical teeth as well. So that's the upper jaw. So again, we have increasing size of teeth, gap, and then big teeth again. And then on the lower jaw, we also have an increasing size of teeth. Um, but the big teeth on the biggest teeth on the lower jaw actually fit into that diastema. They fit
Oh,
to that
wow.
gap. Yeah. So you have almost kind of like a, I don't know what the right sort of like biomechanical word for it is, but like a little extra vice aspect to it where
So
you
they kind
have
of
the,
interlock almost.
yeah,
Cool.
exactly. Yeah. So I wish they had had that because I think that's like a really cool,
Yeah.
unique aspect of that animal's skull. That's really cool. Yeah.
Yeah, and like talking about like its skull overall, how does the one that we see in the films compare to like the one we know from the fossil record?
Yeah. So one thing that I was a little disappointed with is that again, like we were just talking about, Dimetrodon has this like really unique skull, and I feel like they took a Tyrannosaur skull and then kind of Dimetrodonified it a little bit. So
We
it's
had
not.
Natalia Jagielska, who's a pterosaur expert, say the exact same thing about the Dimorphodon.
I was good. Yeah, the second you mentioned Natalia, I was like, oh, the Dimorphodon.
Yeah.
But yeah, which I kind of don't understand because it's also like we were just talking about. This animal has like an amazing skull, and so why wouldn't you want to show off? Like, okay, so we've got all these dinosaurs with these crazy skulls that are like really cool to look at,
Mm,
and I wish they had showed off all the things of Dimetrodons as well.
yeah.
One thing that I do, um, one thing that they did get right in some sense was you can see that there is a hole, like a little depression behind the eye socket. So
Hmm.
there's like a little dip right there. And that's actually a key feature of synapsids, having that singular hole right
Oh,
behind
cool.
the orbit. Yeah.
So they definitely that's really great. So they knew what they were doing in that regard, but then with the rest of it, you're probably right. They thought, well, what do we have as a design that's already like really threatening and stuff? The T-Rex is, it was designed for the first film, looks fantastic, super threatening. Let's borrow some like design DNA almost from that and
Right.
enhance the skull. Yeah. But you're right, like it's got such a really unique skull in real life. It's got like quite a kind of rounded front face, like almost like a pit bull terrier almost. Like that's
Yeah.
the only thing I could think of that has that same kind of rounded face. And it would be nice to see. It really sets it apart from dinosaurs. Like it doesn't look like a dinosaur because of that skull, and obviously the posture and stuff. But that skull is obviously not a dinosaur skull. So yeah, maybe we'll see. Like they like redesigning these animals. So if we see it again, I think that's something we might see.
Yeah. Yeah. And it's interesting too. And it's been neat to see like the Jurassic World franchise do this, but paleo art or, just like making art of extinct animals is very reflective of how science changes over time.
Yeah.
And like public perception of science changes over time. And that's, I think, both in like what animals the Jurassic World franchise represents, and how they represent them is like very reflective of like public perception of extinct animals, which is I think really interesting. So yeah, hopefully we'll see some things updated
Yeah.
on that animal. Yeah.
That would be cool. Just a couple last things to talk about with Dimetrodon before we move on to Lysosaurus is so we've been talking quite a lot about it in the film. It's used as like a sewer gator. We've spoken about its gait being somewhat similar but not the same as a crocodile. Now, there's definitely something else with the design they've borrowed from a crocodile, and that's its skin covering. It's got these almost like bony, like osteoderms, so like kind of bone-like structures like throughout its back in rows, very very crocodilian. And then the rest of its body is covered in kind of your standard like scales. Do we have kind of any inkling, any idea what Dimetrodon's skin covering would have been like in life?
Yeah, that's a great question. So I can say probably almost certainly that it didn't have those osteoderms, like those crocodile-like scutes, because since those are bone, we would almost certainly get those preserved
Right.
with these animals. We have some really stunning specimens of Dimetrodon that are completely intact, and yeah, none of them show evidence of osteoderms. So probably not that kind of covering. But I think scales are absolutely fair. If you look at like just coverings of different animals like today, even among mammals, like you don't see like scales like you see on reptiles, but you see rough, bumpy skin. And so um, that's kind of we wouldn't have hair at this point. Um, I mean, there's no positive evidence, but I'm pretty certain that Dimetrodon wouldn't have hair. Um, but any sort of like leathery, scaly skin, it would make me happy in a reconstruction. Now, one piece of evidence we do have, and it's not direct for Dimetrodon, but just for this whole group of early synapsids, like Dimetrodon, are what we call pelycosaurs. And this isn't like an official like evolutionary family. It's more just like this like amalgamation of animals that were living in the early Permian. And we have um, a belly impression from Poland of a Dimetrodon-like animal. Now, there were a lot of animals related to Dimetrodon that were around at the same time, so similar looking skulls, some having that big sail, others not. But we have belly scales that look like true scales, like they're these like rectangular belly scales. From Poland at the time. So that's about the only evidence that we have. But yeah.
That's great. Well, that's really interesting, though, that even though it might not necessarily be Dimetrodon, that we have kind of skin impressions dating back that far is really, really cool.
Yeah. Yes. Yeah.
That's so awesome.
Yeah, and our like skin impressions of these things are so few and far between. So we like jump for joy every time we get something.
Yeah.
So.
That's great.
Yeah.
That's so interesting. And then you just mentioned there as well about some of the other animals that Dimetrodon shared its habitat with. You mentioned some other animals that had large spines. In the film, we see that it has a taste for humans. There are some human skeletons in their den in the amber mines. And then also, of course, they chase the main cast. In terms of what Dimetrodon would have preyed on, are humans in the size range of what they would have gone for, or maybe other types of prey?
Yeah, I think for something as large as Dimetrodon grandis, we're definitely like in the size range I would assume they would prey on. I don't know if they'd be thrown off by the fact that we are agile and upright in real life. Who knows? But some of the other animals in its environment would be amphibians or like amphibian-like creatures like Ariops and Diplocaulus, sharks like Xenocanthus and other fish, other pelycosaurs, other synapsids, things like Catylorhynchus, Edaphosaurus, Secodontosaurus. Yeah, there's a whole cast and crew. And in terms of what Dimetrodon would have been able to eat, I mean, pretty much, I would assume anything that it could either hunt or scavenge. So little ones probably weren't taking down. So Edaphosaurus is like an herbivorous synapsid at the time, and it had a very different and a like secondarily evolved sail of its own. Its sail almost looks like deer antlers, which is pretty freaky. Wow. Yeah, so it's got these like little processes coming off the side of it. It's a really cool animal.
I think there might be a toy of that from the 90s in the Jurassic Park series.
I think there was. Yeah.
Or at least the Mattel people have done one recently, something like that.
Yeah. If you were to pick other synapsids from the early Permian to do, I would say either Edaphosaurus or Catylorhynchus, which If you haven't seen Catylorhynchus, folks, like look it up. It's got a little peanut head and like a 10-foot long body. It's
Oh, I
excellent.
know the one. Yeah.
Yeah. It's an excellent animal. One of my undergrad advisors was Hans Seuss at the Smithsonian. He's like excellent guy.
Yeah.
And he helped me with like a lot of the early synapsid lore. There's this one meme he loves that's of a Catylorhynchus doing a face palm. And it says something like when a normal face palm isn't enough because they have these huge feet and this tiny head. So it's like completely eclipsing its head.
That's so cool.
Yeah, it's excellent. I always think about that. But yeah, so like a little Dimetrodon probably wasn't going after the big Edaphosaurus or the big Catylorhynchus, but yeah, I would almost assume that Dimetrodon grandis could have picked on anybody in its environment if it wanted to. So
nice.
Yeah.
And you mentioned there that it probably went after like fish and sharks. So bringing it right back round, hanging out near water to catch those as well. That's really cool.
Yeah. So, and that's the thing that I wonder if it was like catching them out of the water, if it was like a thing of them washing up on the shore and then it was like, an opportunity. But yeah, again, who knows? That'd be really cool to see though, if it was like grabbing sharks out of the water.
Yeah. Oh, like a almost. I know they're not related at all. No one get this idea, but almost like a miniature Spinosaurus standing by the banks of a river with a sail, grabbing fish out of it.
Yeah, totally. That is, and like I appreciate you bringing that up because that's one thing that I get all the time is like when I bring out Dimetrodon fossils, is people are like, "Oh my God, Spinosaurus," and like. No relation. This is the OG.
Yes.
Yeah, exactly. Yeah.
Oh, nice one. Okay. Any last kind of bits on Dimetrodon that you'd like to talk about before we move on?
I mean, just that it's an awesome animal. Tell your friends it's not a dinosaur. And yeah.
Absolutely.
Go Dimetrodon.
Yeah, go Dimetrodon. So to round out Dimetrodon, we do this on for every animal that we have a look at. In keeping with the Jurassic Park fashion, we're gonna try and figure out what percentage of this animal's genome was complete in the lab before they rushed it out into the park. So of the percentage of 100, Caroline, what do you reckon with this one? How much of it is the original Dimetrodon genome? And then how much is kind of leftover bits and bobs they had in the DNA drawer?
Yeah, I think a lot of it, unfortunately, would have to be bits and bobs. And a lot of that's because if you think about, again, we're pretty close to that most recent amniote ancestor with Dimetrodon. And so it's very distantly related from mammals. But it's closer related to mammals than it is to any reptile. So we basically have to scrounge whatever scraps we have of early synapsid DNA from modern mammals. And yeah, that might actually be a great explanation for why this Dimetrodon looks so much like a T-Rex in the movies, is because they're like, oh gosh, we only have like these, like we can get the, we call it that little hole behind the eye socket, the postorbital fenestra, and then like there's special structure to the jaw that's like very inherent to synapsids. So it's like, we can get the highlights, but everything else needs to get filled in by the dinosaurs or something. I don't know, but yeah, like a percent. I don't know. I would say maybe like, because I don't know, we share like something like 40% of our DNA with bananas. So I would imagine that would have to be like most mammals.
There's a basic
share a lot of
bit they need to have gotten right.
Yeah. Yes. So yeah, I don't know. Just to throw out a number, don't quote me on this in any kind of academic context, but maybe like 70%. I don't know.
Okay, cool. Yeah, very nice. Very nice. Yeah, these are very unscientific measures. This is literally like playing Jurassic World Evolution. Yeah.
Yeah, exactly.
Okay, great. So moving on to our next species, or even, I guess in this case, genus, Lystrosaurus. This is a really interesting animal and something that you're actively working on. give us the lowdown on what a Lysosaurus is, because this is such an interesting animal.
Yeah. Okay, so we were just talking about like 290-ish million years ago with Dignitrodon.
Yeah.
Now I want you to fast forward to about 252 million years ago. So technically like 255 to like 248-ish. So we're sort of like out of the earliest terrestrial ecosystems. And now to set the scene, we have, again, lush floodplains, probably with some slightly different plants. And now we have all different kinds of synapsids doing all different kinds of things. And Lystrosaurus was an example of a really successful group of these synapsids. So at this point, we've gotten past the Pelycosaurus, and now we're in this group called Therapsids, which mammals are a part of today, so much more closely related to us.
Oh, cool.
And Lystrosaurus is a dicynodont therapsid. So dicynodont means two dog tooth, and in spite of the dog being in there, these are actually one of the most distantly related groups of therapsids to mammals. So they're kind of like, if you can think of, like, if we're like, reptiles have all these different groups of animals in them, right? And so if you think of like birds are analogous to mammals on the reptile side of the tree, dicynodonts are kind of like the turtles of
Right.
of the therapsids. So
very different.
Not direct. Yes, exactly. Yeah. And so dicynodonts, we have like hundreds of genera of these things. And Lystrosaurus is of particular importance because it lived during Earth's worst mass extinction, the end Permian mass extinction.
Mm-hmm.
Now, if you think that the extinction that killed the dinosaurs was bad, which it was, that killed about 75% of all life. And we think that the extinction, the end Permian mass extinction, killed about 90% of all life. And fun fact, it was climate change driven. So, yeah. So this was a really bad extinction. And in spite of how terrible it was, Lystrosaurus seems to be the only thing that was doing well at this time. So while we have scant fossils from pretty much every other group of animals on land, we have literally thousands of Lystrosaurus fossils, which is part of why I work on this animal, because we have this incredible sample size. Yeah.
Wow, thank you for that. Yeah, I knew it was a special one because there was the end Permian is it the Great Dying? Sometimes people refer to it as that. Over 95% of all land vertebrates went extinct, but somehow Lystrosaurus made it through and then, became such a widespread like animal.
Mm-hmm.
Like that's incredible.
Yeah.
Which is really fascinating because in the film we've got one, and I think it's called Leonard. It was given that nickname by the actor, which is really cool. And there's one bit in which one of the characters say that's incredibly rare, which is hilarious. Like it of all the animals they've had in Jurassic, this was the most numerous around the planet. And in the films, it's the rarest one. I don't know if they did that on purpose, but it's quite ironic.
It was so funny to me. And yeah, it's because it truly, like, if you want to find, there's a great quote from, sorry about the dog. Yeah, so James Kitching, who's this like really famous South African paleontologist, he's quoted as saying, "I do not bend my back for Lystrosaurus while doing field work." And I always joke that I do bend my back for Lystrosaurus in the field. Like any Lystrosaurus skull I see, I'm like, gotta pick it up for the sample size. But yeah, it is so abundant that people, like, if we're out in the field and we find Lystrosaurus, people are like, oh, because they want to find something cooler and like another Lystrosaurus skull. So yeah, if you're thinking of like a fossil vertebrate that would be like super abundant, Lystrosaurus is like one of the best ones. So.
That's just a hilarious kind of juxtaposition. Talking about its discovery, it was first discovered around the same kind of time as Dimetrodon, and it was I like this little story that it was discovered in South Africa in the 1860s, and it was discovered by someone from the USA who was a missionary there. They actually wrote to Edward Drinker Cope's nemesis, Othniel Marsh, about it. Had no response, so then Cope got involved after that, which is really, really funny that those two, that their bickering comes up all the time on this podcast. They're everywhere. But yeah, but am I right in thinking that since then it's been there's been so many species that have been found all over the southern hemisphere?
Yeah, 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 and historically, so we find Lystrosaurus all over the world. So we have Lystrosaurus from South Africa, from India, China, Russia, and even all the way down in Antarctica. We have a ton of Lystrosaurus from Antarctica. And it actually, this is just like a sidebar fun fact, helped prove plate tectonics. So
Oh,
it was yet
cool.
another piece of supporting evidence that plate tectonics was real. So thanks, Lystrosaurus, for that. Yeah, and so across this like broad distribution across the globe, we see a few different species. So the current estimate is about 5 to 7, and currently my PhD work is focused on revising the taxonomy. So there's a few different things I'm working on, but one of my research focuses is on making sure that our taxonomy of Lystrosaurus is clear from South Africa. And yeah, there's probably about 3 to 4 species in South Africa. But in the past, have been dozens of species named. And part of that was kind of like to your point about like Cope and Marsh, it's like different paleo rivals, like trying to name more species than the other. Part of that too was that every time there was a Lystrosaurus found in a slightly different location, and a lot of these animals are preserved and tectonically active. So like you know, plate tectonics is squishing and squeezing the crust, and as it's squishing and squeezing the crust, the fossils get squished and squeezed as well.
Yeah.
And so you get Lystrosaurus skulls in some pretty funny shapes that have been interpreted as different species when they're actually just squashed. So
It's quite funny.
yeah, yeah.
So with all those different species, them, and like you mentioned, like different kind of, some were maybe not different species, they were like squashed, but lots of different sizes. The one that we see in the film, Leonard, is around 1 meter long. Is that what we'd expect from some of these species?
Oh, absolutely. Yeah. The largest specimens I know of are probably no more than 1.5 meters long. So like, yeah, that's a perfectly, probably right down the middle. Yeah, size for these animals.
Cool. And in terms of, so the size is about right. In terms of its overall kind of appearance, like it's got that sprawling gait like we kind of saw with Dimetrodon and stuff. How does that kind of stack up in terms of its overall kind of body with what we know of those kind of larger species?
Yeah. So I love this reconstruction because of how iconic it is, but if you were to ask me on the accuracy, they really did my boy dirty here. So the skull of the animal, we can chat about that in a bit. But the limbs are, so Dicynodons probably had, so this big group of animals with hundreds of genera that Lystrosaurus is a part of, probably did have a little bit more of a sprawling gait in the forelimb, but then in the hind limb probably would have been a little bit more upright. And we can tell that just from looking at the shoulder and the hip structure. Yeah, and sort of the really bow-legged posture that we see Leonard having, I kind of attribute that to poor Leonard living so much of his time in a cage.
Yeah, tiny little cage.
But yeah. But the body of Lystrosaurus, when people ask me how to reconstruct Lystrosaurus, along with just like more detailed notes, and sort of like vibe that I tell people to do is like pygmy hippo plus giant tortoise. So think like the Mudangs,
Yeah.
the Emperor. Yeah, just like cute, ugly to the max. So it should be like a lot more chunky.
Yeah.
And yeah. Yeah, we can talk about the skull a little bit too.
Yeah. I love that analogy though, kind of like an ugly moodang. That's
Yeah.
that's really good.
Exactly. Yeah.
Yeah, I'd love to hear more about that skull. Yeah.
Yeah, this skull, I was kind of confused by again, like how they did the skull, because they took like I don't know, like a non-frilled ceratopsian, like a Leptosaurus type animal, and they kind of tried to Dicynodontify it. But if you were to show me that skull or like this reconstruction and be like, what Dicynodont is this supposed to be? I actually probably, well, given the face is so flat, I probably would still say Lystrosaurus, but it doesn't look anything like a real Lystrosaurus
Oh
skull.
wow.
Yeah, so the back of the skull, yeah, it would have been a little bit shorter and looked, it's kind of hard to describe it just verbally. But its jaw muscles, like the holes for the jaw muscles, would have been oriented completely differently. The eyes are much more higher set on the head, so he's got these very low set eyes.
Yeah.
But Lystrosaurus had like really almost sort of like mud skipper set eyeballs and like high nostrils. And I know this happens to ceratopsians and paleoart as well. Like one pet peeve of mine is like how beaks are often done and like keratinous covering, so like that hard sort of like fingernail type material covering on the face of both Dicynodonts and ceratopsians. Because if you look at like a bird without feathers on it and like turtles, that keratin like very much grades with the skin.
Yeah.
And so on a real Lystrosaurus, it would have had a much more sort of turtley. We have, if you look at the skull, there are these like little pits all over certain parts of the skull that we call the like jargony word is nutritive foramina, which basically means holes where blood vessels come through.
Right.
And we see the same thing on animals today that have keratin or like other kinds of tissue covering that part of the bone. So Lystrosaurus's face would have had much more, again, like turtley sort of rough look to it than we see Leonard having.
Right.
Yeah.
Right. I can't help but feel like some of those choices, like the nostrils and the eyes, those were kind of done to make Leonard more of a character, because it is such a character in the film. Like, bring the eyes together makes it more like a dog or something. Like, yeah, they've definitely made it feel a lot more, yeah, mammalian, I guess.
Yeah. It's, and there are some Dicynodonts that have much lower set eyes, which is part of why I was like, this doesn't look like Lystrosaurus. But yeah, there's a lot of skull diversity among Dicynodonts. Like you go from like little tiny gopher-sized animals that probably live their lives like a mole,
Yeah.
elephant-sized animals, and Lystrosaurus is somewhere in the middle. So yeah, maybe they pulled from like a bunch of different flavors of Dicynodonts to make Leonard.
Maybe that's why Leonard's so rare, because the genome's so unstable. It's a whole jumble.
Yeah, we can't make another one.
Yeah.
So funny.
This is one of 1,000 that works. Yeah.
Yeah, exactly.
Just while we're talking about the skull as well, so like that's, like you mentioned, its beak, and like that's how it got its name as well, like shovel lizard, because it's got that kind of beak. Now Leonard knows how to use his beak in this movie. Let's say there's multiple scenes where he's in a fighting ring. One of them is an extended cut where he just straight up decapitates an oviraptor, like without any problems. Just cuts through its whole neck like butter. What's up with that?
And then spits the feathers.
Yeah,
I love
spits the
that. They
feathers.
so see like bites and then he spits the feathers out.
Yeah.
My supervisor is like also a Dicynodont expert. He's like the guy who like got me into Dicynodonts. Ken Angelsic is an amazing guy. But so when I saw that extended cut clip, I was like ran into his office and was like, stop what you're doing. We gotta watch this right now. Yeah, I mean, we don't know how strong Lystrosaurus's bite probably was, but given that it was using that deep jaw mostly for grinding at plants, I don't think it would have had many opportunities to be snapping necks in half. but it just made me so happy to see it. It's like, yes, the Dicynodon got the dinosaur. Because like our guys get like no love out in the world, and just seeing like, oh no, this poor raptor got wrecked by little Leonard was pretty awesome.
They finally got a win.
Yeah, literally, yeah. It was so, yeah. I watch every once in a while when I need to laugh. I like watch that scene and just like, especially, I think there's like another one where he's like ripping into that guy's hand.
Yes, yeah.
It's so good. Yeah.
It like teams up with
so
like a
happy.
baby like Carnotaur and like a baby Baryonyx to like hold that dude down.
Yeah.
It's such a cartoon moment, but yeah, it's hilarious.
Yeah. No, that just made me so happy.
So yeah, I guess not too clear on their bite force. And as you mentioned as well, like it was a Elysiosaurus would have been a plant, a herbivore. And in terms of its disposition, like, I mean, once again, this might be hard to tell, but like Leonard is a feisty little guy. Like it's not just that Oviraptor, like as you mentioned, like it pins down Rain Delacour, which is a hilarious name. It's just hilarious. I can't say it without laughing. And yeah, he's moody, right? Do we know anything about their disposition? Is there any kind of like aspects of their social life we might know from the fossil records? Anything like that?
Yeah, so we get some evidence of behavior from Lystrosaurus. One is, so around the time of the end Permian mass extinction, this is like pretty grim, but we have a ton of juvenile mass death assemblages of Lystrosaurus.
Whoa.
Yeah. And the smallest Lystrosaurus skull I've seen, so the biggest one that I've seen has been a little over 30 centimeters front to back, and then a little bit more than that top to bottom. Again, I have this like really deep skull. And then the smallest that I've seen has like been barely over like 3 centimeters. So just like a little gumball sized head. Yeah. So we have like neonate / infant like specimens of these animals. Another thing we know about them is that they, at least the juveniles, were burrowing. So a lot of synapsids, a lot of therapsids at the time of the end Permian mass extinction were utilizing burrowing behavior, presumably to escape the harsh climate at the time. And we see a lot of juvenile Lystrosaurus employing that as well. We don't know. So the huge adults probably weren't excavating like tunnel systems, but you know, you see like, you know, large animals today like aardvarks, or you know, even like hippos and rhinos and stuff, like sort of scratching out, you know, either places to rest or, you know, digging up things to eat. So so digging was definitely a facet of their biology. And then again, juvenile aggregation. Yeah, we usually find when we find Lystrosaurus fossils, it's hardly ever like, you know, if we're at a particular site, you know, even if they're sort of scattered, like, oh, there's one here, there's one there. You know, if there's one Lystrosaurus, there's probably more. And there's places like, I haven't been to this site, but one of the places that my supervisor has been to in China, he told me that it's just like a polka dot fabric of Lystrosaurus skulls going up this like one like rock face.
Wow.
Just like completely unexcavated, just Lystrosaurus skulls everywhere. So they're probably decently social with one another.
That's incredible. That's fascinating to think that. Yeah, way before the dinosaurs, there were these little kind of sort of cute creatures running around in like little social structures, burrowing. And yeah, have you ever seen Primeval, the UK TV show? Yeah, they've got what were those ones? They've got a couple of these Dicynodonts in there in series 3, Sid and Nancy.
Yeah, I can't remember which ones exactly. I remember they like terrifying Gorgon.
Yeah, I think they were Diictodons, I think is what they called them.
Yes, I love Diictodon. So Diictodon was more middle Permian, so kind of sandwiched in between where Dimetrodon and Lystrosaurus was, but it's again one of those, again, a dicynodont. And actually, I say Middle Permian, but Diectodon was one of the longest lived dicynodonts to live from the Middle Permian pretty much all the way up to the extinction. So it was a very
Wow.
long lived animal. And that's another one that we have like thousands upon thousands of. And it's a much smaller dicynodont, and it was also a burrower. And we have so many like burrows with diectodons in them, and like multiple. So you'll have like one curled around the other, which is really sweet. Yeah, yeah. Like little tiny babies recently. Um, there was this beautiful fossil described that I think was both CT and synchrotron scanned. So yeah, some pretty intense scanning technology used on it. And not only was there an adult in this burrow, but a neonate whose
Wow.
skull was, I think, like a centimeter or two across, like tucked underneath this adult. So I don't know, like that's not necessarily direct evidence of parental care, because who knows what the situation, preserving those two were. But yeah, especially with our tiny dicynodonts, we have all these like beautiful, like, I don't know if you've talked about the Triassic kettle or.
It's not really come up.
So for those of you out there who haven't heard of the Triassic kettle, it's this wonderful fossil of yet another kind of therapsid cynodont, which is a direct relative of mammals. So this Thernaxodon crawled around this little amphibian called Brumastega, in this burrow. And so it's thought that, either one was washed in with the other, or they were, experiencing the worst of the extinction and just died together in the burrow.
Whoa.
Yeah. So it's very like, it's really sweet too, because it's, I find that synapsids are becoming more and more popular among just like paleo fans in general on the internet. So there have been all these like wonderful pieces of art that I've seen on like Tumblr and Instagram of that fossil. But yeah, there's so many beautiful examples of animals like huddling together during the Permian and burrows. And it really is this like it's sad, but it's also like this beautiful thing of like, they're sticking together through the worst of it. And yeah, so we see Diectodon doing that too.
Oh, wow. But actually, on that note of burrowing and such, in terms of like why that would have been useful and linking it back to what we see on Leonard, is that in the film they've given Leonard's like quite in terms of scales, like the Dimetrodon, it's more of like a skin-like covering, and there's even some kind of early kind of hairs or fur as well on Leonard. It looks kind of a bit kind of like a rhino skin, if there was any kind of Monday analogy. And then talking about them burrowing, was that maybe for warmth? What do we know about their skin covering, and yeah, if that would have helped keep them warm?
Yeah. So we recently found what we think is a mummy of a Lystrosaurus. So we find a lot of Lystrosaurus skeletons spread-eagled, and we have kind of inferred, kind of based on what we were talking about Dimetrodon earlier, and then like modern day animals, that dicynodonts would have had this sort of leathery rhino hippo like skin.
Yeah.
And yeah, it seems like there are a few people who are working on figuring out what exactly is going on with the skin on this mummy. But we do have some like probably direct evidence of the skin covering on Lystrosaurus. Now, as for hair, this is a point of great contention among synapsid paleontologists. So ask any of us and we'll all have different answers. We'll pretty much all say, do not put hair on Dimetrodon. But yeah, I kind of feel like one thing for me that drives me a little crazy is sort of the with like a little bit of hair thing like they did for Leonard. I want to see commitment if we're putting hair on these things. And I honestly don't think that it's probably unlikely that dicynodonts had hair. Again, they're kind of like an offshoot. It'd be like putting feathers on a turtle is kind of like the way to think about it.
Yeah.
But where the discussion gets really interesting about that is Um, kind of going from there are these other groups of therapsids called Gorgonopsians, which if you've ever seen like the big saber-tooth guys, like we were talking about primeval,
Yeah.
Therocothalians, which are another sort of mammal-y looking group, and then cynodonts, which include modern mammals.
Mhm.
There's a debate as to like where and when hair popped up there. And unfortunately, we don't have direct evidence until we hit the Jurassic. So we have this little animal called a docodont, which is an early kind of mammal that looks like roadkill, and it just has, like you'd see if a possum had get smeared on the highway. There's just like a pff of hair all around it, like this puff. But there are putative coprolites, so fossil poop from the late Permian that may show hair. A lot of us are skeptical. But yeah, it's really up in the air as to where hair is in the tree. If you ask my advisor and people who also sort of subscribe to his like model of evolution of mammalness, it wouldn't be until you hit like late cynodonts, so really mammal looking animals, that he would feel confident putting hair on them. And I'm a little bit more of a like, well, I like the idea of some of the earlier ones looking fuzzy. So I'm a little skeptical about the saber-toothed ones, so like Organoxians having hair, but basically things after that, I'm kind of like, okay, I see hair on them. So
All right, so no hair for Leonard, but the jury is out on some other ones.
yeah. And you also asked about the burrowing and what it was used for, and I didn't.
Yeah. I was wondering if that was to keep warm, or it'd be interesting to know.
Yeah, so like animals today, in hot climates often burrow for thermoregulation. So like if we're thinking about Pangea at this time, we're having these really intense temperature swings, probably, especially in dry areas. And so during the day, the burrow will be cooler than outside, and during night, it'll be warmer. So almost certainly, especially if you're like a little Lystrosaurus, like, and if you're a small animal, you don't retain heat as well, especially if you're not warm-blooded yet. So yeah, it was probably for both protection, so you're harder to get to from the Gorgons, and then also for thermoregulation, so making sure they're staying a good temperature.
Okay, well, there we go. I think it's time to do our Dino DNA ranking, or Lystro DNA ranking, for this one. So we had 70% for Dimetrodon. What are we thinking for our friend Leonard?
Yeah, I would probably bump. Well, it depends on. Yeah, I was gonna say it depends on whether. So, like, if I was thinking in terms of like, okay, like Lystrosaurus is more closely related to mammals, I'd probably say 75%. But given that Leonard looks so much like a Leptoceratops mixed with, I mean, I said when I first saw it, he kind of looks like Leptoceratops mixed with Yoda.
Yeah.
Like the little hairs and stuff.
Yeah.
So I don't know, maybe we'd keep him around 70% just because, yeah, he's got some unfortunate qualities to him, which is why we love him. But,
yeah.
Yeah.
This is why we stand Leonard.
Yes, yeah. I have a little Leonard. One of my students gave me this like adorable little Leonard model.
That's
And
cool.
yeah, he sits on my desk and watches me work on all the Lystrosaurus skulls that I work on. So
Leonard has fans everywhere. Hopefully we'll see him come back in a future film. Yeah.
Oh yes, please.
Oh, well, it's been lovely hearing everything about these non-mammalian synapsids. Thank you so much for joining me. I had one final question that wasn't about these animals, and that was if there are any like young people who are listening that are interested in paleontology, what would be your advice to them in terms of getting into the field?
Yeah, that's a great question. So the first thing I want to say is that there are so many ways to get involved. So like, even if you're like 25 listening to this and you're like, man, I picked the wrong career and I want to get into paleo. Like, there's so many ways to get into it, like regardless if you're 5 or 35, you know. And my path was like more or less linear. Like, I was interested in science as a kid. I had this great high school science teacher who let me do like a geology project for my science fair, and it kind of went on from there.
Cool.
But like, one thing I would say is like find people who are going to support you, because a lot of my progress was not possible without amazing mentors. So so without Mike Williams in high school, I wouldn't have wanted to continue. Without volunteering with Len Wingard, working on like Holocene and Pleistocene mollusk shells, I wouldn't have like known that there was a career that I could do. That my undergrad advisors, Hans Susero and Lockwood, I wouldn't have felt supported in working on my Dimetrodon project. And like, Ken Angelsic has been a wonderful supporter for me throughout my PhD, and like supporting not just my scientific career, but just, professional career as well. So find your people and then just keep asking questions. So like, a lot of times, especially for those of us who work on like more quote unquote obscure groups, we are so excited when we get emails from people asking questions or asking like, is there an opportunity for me? Like, one of my students, I started working with her because she emailed me saying, I don't want to work on like flies for my science fair. Is there any way I can volunteer at the field museum? And I was like, yeah, come on over. And now she has a project on Listersaurus and its relatives. So reach out to people, and then just like keep up with people, and stay interested, learn as much as you can. And even if you're not good at a certain area of science right now, like I was terrible at physics in college, and I'm not a biomechanist. My partner's a biomechanics person, so he can think about the physics, but like you don't have to be good at everything to be a great scientist. Like, you just have to be curious and creative and persistent. So
Fantastic. Thank you so much. And where can people find your work and follow you as well?
So I'm at Dimetro_dingus on Instagram, and then at Dimetro_dude on both X and Blue Sky. And if you want to send me an email asking questions, that's cpabbott@uchicago.edu for any questions you might have. And I don't have a website yet, but I should get on that because I'm getting ready to leave the PhD. So
Great. Well, thank you so much for joining us, and best of luck with the rest of the PhD. It's been an absolute pleasure having you.
Yeah, thanks for having me. It's been so fun to talk about these guys again. Like, I am thrilled that the Jurassic World franchise is starting to represent Synapsids, and I can't wait to see what they'll do in the future. So
Me too. And for everyone who's listening, you can find me at Conor Ontology. And also, please do follow the Jurassic Park podcast over on Instagram. There's a Facebook group as well. And also on Blue Sky, you can follow myself, the podcast, Brad Jose, and of course, Caroline. Hope you've enjoyed listening, and we'll catch you next time. Goodbye.
Life will not be contained. Life breaks free, it expands to new territories, and crashes through barriers painfully, maybe even dangerously, but, there it is. There it is. I'm simply saying that life, finds a way.
That'll do it for another episode of the Jurassic Park podcast. We appreciate each and every one of you for listening and sharing in our love of dinosaurs in this, maybe not exactly dinosaurs, in this Jurassic franchise. Of course, I'm like, let me just say dinosaurs. And then as I'm saying it, I'm like, well, wait, the things that they talked about today were not actually dinosaurs. But that's what I love about this kind of topic here, in this segment specifically, can really define exactly what we're looking at in these films. And I think, Conor and Caroline really did such an incredible job here today, just deciphering what we see based off the fossil records and what, the actual findings are and what we see in the movies. So I love it. I love it so much. This one was incredibly informative. So I appreciate both Conor for putting this one together and Caroline for joining us here on the show. An absolute treat. So thank you so much. Be sure to go follow both of them over on their social platforms. And as I try to do from time to time, I try to focus on the reviews that we get over on Apple Podcasts. So I wanted to shout out here one from Spring Locked Bunny, which came a few days ago. And this says, "Oh my God, this show is awesome." We got a 4-star review there. Thank you so much for that. And it says, "Man, you got me in the groove. Love this Jurassic World podcast. You're the best out there." So thank you very much, Spring Locked Bunny. I really, really appreciate you writing that and enjoying the podcast. So I appreciate that. But we've got a lot of really fun stuff coming up. So I think it's just going to get better and better. Hopefully, I'm going to try to put forth my best effort. I don't know. There's a lot of fun stuff coming up. We've got so much to discuss. Like I said in the intro of the show, a new movie, new video games, new toys and merchandise, new TV show stuff. We got a lot to talk about. New dinosaurs out there to discuss. It's going to be a heck of a time, and I can't wait. So if you want to go ahead and leave a review in the future, please head over to Apple Podcasts, write a 5-star review, leave something in there, or a 4-star like today. Whatever number you feel is appropriate, leave that amount of stars, and we'll go ahead and read them on the show. And if you do so over on Spotify, please, another 5 stars as well. That'd be awesome. But as always, thank you to our podcast host, Podomatic, for giving us a place to upload the podcast each and every week. Everybody out there, please just know that you matter a ton, more than anything. Please stay safe, be kind, fight for representation, change, and equality in the Jurassic franchise. But more importantly, outside of it, in the real world, where it actually matters, especially these days. It's only February, the start of February, and this is what it's like. But please, let's make sure to make the world a better place. I'm going to go ahead and hand things off to myself for the outro. Take it away.
Saddle up, let's get this movable feast underway.
Continue the conversation with us on Threads and Instagram. Watch our content on TikTok and YouTube. Find us on the web at JurassicParkPodcast.com. You'll find today's episode show notes, articles, contributor bios, and so much more. You can listen to us on Spotify, Apple Podcasts, our website, and wherever else podcasts are found. So please be sure to follow along and share with your friends, family, and fellow Jurassic fans. If you haven't already, please give us a 5-star review on Apple Podcasts and Spotify. We will read your Apple reviews at the end of most episodes, so be sure to spare no expense. Don't miss our Wednesday night live streams, toy hunts, reviews, in-depth bonus content, gameplay, event and theme park coverage on our YouTube channel. If you want to get a hold of us or participate in the Jurassic Mailbag, you can fill out the contact form on our website or send emails and MP3s to JurassicParkPod@gmail.com. Feel free to call our voicemail line at any time to leave us a message or just to say hi. That number is 732-825-7763. Thank you so much for listening, and as always, enjoy.